Okay, and what we have here, guys, is find the solution set G to the following. So it's 3x minus 1 less than or equal to 9 minus 2x. Bring the 2x over to the 3, we're going to get 3x plus 2x less than or equal to 9. Bring it over to 1, becomes a plus 1. 5x less than or equal to 10. X is less than or equal to 2. So that's the first part done. That's part 1. Now we're going on to part 2. 1 minus 3x less than or equal to 8 minus x. Bring the x over to the other side, minus 3x plus x. Bring the 1 over to the other side, and we get, how do I get a fraction? Is that correct? Fraction, that's unusual. How do I get a fraction? What? You're about to get a fraction, were you? Yeah, I'm going to get a fraction as well. So, alright, so we're going to get 8. It's supposed to be a 1 on the left, which makes it a minus 1 on the right. We're going to get minus 2x less than or equal to 7. I'm going to multiply both sides by minus 1. What happens when I multiply both sides by minus 1? Just sweep that around. Then I'm going to say x is bigger than or equal to minus 7 over 2. Or it's the same thing as minus 3.5. Has anyone got any questions? Thomas? Now, guys, we have a number line to draw, don't we? I got to get both answers and I got to fuse them together. So look at this. I want all the numbers that are bigger than, I don't know why I have a yellow line. Here's a black line, okay? We go from, let's say, minus 4, minus 3, minus 2, 1, 0, 1, 2, 3. Okay, is it x element or, lads? X element or, okay. First of all, is the 2 included or not included? How do you know it's included? The equal sign. Alright, minus 3.5. That's here, isn't it? It starts in the middle of the line, doesn't it? So it's just from here. It's unusual for it to be a decimal answer, but look, we'll roll with it. Is that okay with you guys? Okay, you guys try 31. I'll wait 2 or 3 minutes and then come in after you, okay? Okay, so it gives you an inequality, and what it just says is that this represents P. So, in essence, Keane, I'm not even looking at that. I'm just looking at that. Okay? And I'm going, okay. Instead of x's, they have t's, don't they? So it's going to be 4t minus 1 less than or equal to 3.
Good afternoon, all classes. Just announced.
Okay, guys. So, 4t less than or equal to 4. T less than or equal to 1. So I just park that off to the side. So once again, Keane, I'm not really looking too much at this stuff here. I'm more looking at what this is here. So once again, 5 minus t less than or equal to 8, minus t less than or equal to 8 minus 5, minus t less than or equal to 3. Not happy with the minus t, so what am I going to do? T greater than or equal to minus 3. Now, the last one asked me to find P and Q. Intersection means and. So P was the first answer, Q was the second answer. Join them together and make a number line out of them. Okay? So what do we get here? Minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay. Is it a filled in line or is it dots? How do I know? Okay, next thing, where do we start? Minus 3. Included or excluded? Included. 1 included or excluded? Shaded in. Did anybody manage to come up with something like that? Okay, good, good, good. 32. Write an inequality to represent each of the following shared sections of the number line. I'm going to try the first one out. Ready? Would everybody be happy with x less than 3? X element z. I made 2 mistakes, not just one. I made 2 mistakes. Anybody care to share my mistakes? Yes, sir. Less than or equal to 3 would actually include the 3, which is great. That's one mistake sorted. I need the second mistake is still there though. Yes, Tom. Yeah, it can't be z because that would go on forever, wouldn't it? So it has to be natural numbers. So that's one answer. X element n. Can anybody in the class give me another way of writing this answer? This is the answer to part 1. There's another way you could write the answer. Yes, Tom. X squared and equal to 1. X smaller than or equal to 3. X element n or x element z. Why can it be either one? Yes. Yeah, there's a start and a stop, isn't there? So if once it's a dot, it's okay. Yeah? What way can I write this? Anybody know a different way I can write this? Payment? And then what do we do then? Everybody happy with that? Anybody can think of even a different answer again? I have another way of doing it. Anybody care to tell me how? 0 less than x less than 4 x element n. Does that work? Think about it. What's the first? 0 is not included. Is 0 included? What's next? 1, 2, 3. Is 4 included? Is that also a viable answer? Yeah. So I don't want you just to have one answer for these. I'd like you to maybe make up 2 answers per question, just to show that you can think outside the box and you can make different variations. Right now, what I want you to do is let's go for part 3. I want you to think, I'll give you 2 minutes. I literally want you to come up with about 3 different answers for. Go with it now. We'll try and find 3 different answers for this. What's your first answer, sir, for part 3? -2, yeah. Less than x, yeah. X less than 5. X element z. Could you use x element n? No, because it has a negative number. Is this a viable answer? Is it a good answer? It is, isn't it? You draw it out, it looks exactly like question 3. No bother. Somebody care to give me a second answer? Yes, sir. Yeah. Less than or equal to 4? Yeah, that'll work. Can you tidy that up for me and give me one inequality? Spin it around. -1 less than or equal to x, and then less than or equal to 4. Yeah, that's perfect. And x element z. Perfect. Anybody else? We're good? Perfect. The other 2's are r's, aren't they? That one is just like x less than or equal to 5. X element r. See the way it goes on forever? And then this one here is just x greater than or equal to 3. Once again, x element r. Right there, pretty handy. Now, let's move on. 32 and 33. Write down the values of x that satisfy each of the following. X plus 1 less than or equal to 6. X is a positive even number. Move it over to the other side. X less than or equal to 5. Is 5 allowed? Why is 5 not allowed? Has to be positive and even, so no good. 4 allowed? 2 allowed? 0. 0 is not considered to be positive, so the answers are just 2 and 4. Let's try question 4 then. 2x plus 5 less than 27. X has to be a prime number. What are the prime numbers again? 2, 3, 5, 7, 11, 13, 17. Okay, we'll stop there. I don't think we'll need them all. Bring 5 out the other side, what happens? Minus 5, which is 22. X less than has to be a prime number. Is 11 allowed? Not allowed because it's not less than or equal. It's just less than. So you're not allowed 11. So automatically you're not allowed 11, 13, 19 and 23. What numbers are you allowed? 2, 3, 5 and 7. Any questions? Right, let's keep going. Triangle. Now, is the following a triangle? Actually, wait a minute. I wonder if he's going to go for the triangle inequality as well. Yeah, we'll give this a go. Let me see. Find the range of values for which the triangle exists. Can somebody do me a favor? Can somebody... So, an example would be this, okay? You have x on one side, 2x minus 3 on the other side, 2x minus 1 on this side, right? Test out a few numbers. Why is 0 definitely not allowed? Why is 0 not allowed? Yes, sir. You can't have a minus length, can you? What's 2 times 0 take away 3? How can you have a triangle of length minus 3? Doesn't work, does it? No. X equals 0 doesn't work. What about x equals 1? 2 times 1 take away 3? Does it work? No, because once again it will be minus 1. Won't work. But here's where I get a bit... Here's where I don't fully agree with the back of the book. I know x equals 2 works, that's no bother. Does x equals 2 work? 2 times 2? Take away 3? 1. 2 times 2? Take away 1? So that'll be a 1, 3, 2 triangle. Are you happy with that? Alright. Did it say x greater than or equal to 2? X greater than 2? Perfect. I'm going to tell you why. Now I agree with it. Can anybody tell me why? In a triangle, 2 sides have to be greater than the third side. Any 2 sides added together have to be greater than the third side. Look at this, for example. You're going to get three colours. 1, 2, and just for argument's sake, I'm going to put them beside each other. And 3. 3 colours, yeah? This is what's known as the triangle inequality. Okay? Look what happens when the red and the blue equals the green. In the same way, 1 plus 2 equals 3. How can I make a triangle out of this when both the red and the blue side added together are the same as the 3? They're going to be lying as a flat line, aren't they? But what happens when I pull the red up? So actually I'll do a circle just to show you, just to really hit the point home. Can anybody tell me why I'm drawing a circle? No? Fair enough. Alright. Oh no. Alright, just get you out of the way for a second. No. There we go. Right. This can only go, see the blue? By having it on a circle, am I changing its length? Not changing its length, am I? Because it's keeping it the same. Now look at the red and the blue. Is it big enough to bridge the green? It's not big enough, is it? It's only big enough when they're flat / together. Does that make sense? That's why 2 plus 1 equals 3 can't happen. That is a straight line. I need my x value to be bigger than 2. Pick a number bigger than 2 as an example. 3. Let's try 3. Shh. 2 times 3, lads? 6. 6 take away 3? 3. 2 times 3? 6. Take away 1? And then finally, the other one is 3. Pick any two sides and add them together. I guarantee you they're bigger than the third sides. Think about it. 3 plus 3, bigger than 5. 5 plus 3, bigger than 3. For a triangle to exist, any two of its lengths added together must be bigger than the third length. Observe below. If I want this triangle to exist, there we go again. Alright. So if I want this triangle to exist, they're currently, the blue and the red currently equal the green at this point in time. However, if I want this triangle to exist, I got to extend the blue further. Do you see that? Now what happens? I can guarantee you that the red one plus the blue one is definitely bigger than the green one. Would everybody agree with that? And that's what has to happen with the numbers. Any two numbers combined have to be bigger than the third side. Yes? Same deal. An equilateral triangle would be, let's say, 3 sixes. Would you be happy with that? 6 plus 6 is 12. 12 is bigger than the other. Two sides added together are always bigger than the third sides. Alright? Alright, let's move on. 40. You keeping track still? Okay, 40. Guys, with question 40, we have Kevin needs to buy a new car. Must trade in his old car. Car dealer offers him a trade-in amount of 4,500. That's how much money he gets for his old car. But only if he spends at least 10,000 on a new car. Okay. If he buys the cheapest new car he can possibly buy, which is 10,000 euro, would you agree with that? How much is he actually going to pay for it? Considering he gets a discount of 4,500. He's gonna spend 5,500 for a 10,000 euro car. Does that make sense? The car costs 10,000 euro. He gets 4,500 euro scrappage, which means he only needs to pay 5,500 euro to bridge the gap. However, he only has 12,500 euros worth of cash. Add that to the scrappage amount, and what you get there? He can afford a 17,000 euro car, can't he? Would you agree with that? Now look at the question. Write an inequality next to show the range of money he could spend in the dealership. Well, he doesn't have to buy a new car, does he? Does he have to? Wants to buy. Well, look, I'd give two answers. I'd say the first one is you don't have to buy a new car. You could buy in the dealership. You could buy a new wheel for all I know. So you could spend anywhere from 0 up to 12,500. My second answer would be if he wants to walk away with a new car and get rid of his old car, the answer would be 5,500 all the way up to 12,500. Would that make sense? Why is the cars he can afford? What's the lowest car he can afford? Actually, that's a good point. He can afford to show the price range of cars he could buy. He doesn't have to buy a car. What's the cheapest car they have? Could be £1,000 for all I know. Would you agree with that? If he has to trade, let's assume he has to trade in his car. What would be the amount if he has to trade in his car? He can get a 10,000 euro car all the way up to anybody? 17,000 car. Alright. That's all.